Hello and welcome to the area of the missing slice. Today we're going to find the area of the missing slice of our circle. We're going to start here with our complete circle, and we know from previous lessons that a circle is a two-dimensional figure in which the edge is always the equal distance from the center. And with this circle, we're going to cut a slice out. We're going to cut from the top down to the center point, and from the right edge to the center point. And we're going to just cut our little piece out, and we're going to make it disappear. So there goes our missing slice, and we're going to come back later and find the area of that missing slice. So to start out, we're going to start with the complete circle because we know how to operate on a complete circle. We know that the area of a circle is pi r squared. That is the formula for the area of a circle, the inside part of the circle. And whenever we operate on the circle to find the area, we start with the diameter, which is represented here by the black arrow from top to bottom vertically. And from the diameter, we can find the radius. So let's give our circle a diameter of 6. So there is our diameter, vertically represented by a vertical line here in red. And from the diameter, we know that we can find the radius because the radius is 1/2 of the diameter. So, because we have a diameter of 6 and the radius is 1/2 of that, we multiply 1/2 times 6, which gives us a radius of 3. So we know that our radius is now 3. So if we plug in our formula, pi r squared, we know that pi is 3.14, and we know our radius is 3, so we're going to square 3. So our equation is 3.14 times 9. 3 squared is 9, which gives us the total area of 28.26. So now we know that our total area of our circle is 28.26. So there's our missing slice. We found our missing slice, and we need to find the area of this slice. In order to do that, we're going to go back to our circle, and let's find the largest piece. We're going to operate on the largest piece because we know the total area of our circle. And if we look at our vertical line and the cut, we see that it goes from the very top to the center point. And since we cut horizontally, we know that the horizontal line goes from the right edge to the center point. And that forms a 90-degree angle. That 90-degree angle is called a right angle. We also notice that if we add another vertical line, it goes all the way from the top to the bottom of our circle. So we have 2 times the radius. Our yellow line is our radius, and if we add another one, we now see that it's 2 times, which represents a vertical line all the way from the top to the bottom. And similarly, if we add another one across horizontally, we can see that it's 2 times the radius as well. And what we can do with that is that we can see that we can actually bisect, we can cut in half our circle from top to bottom. And we can also cut our circle in half, we can bisect it horizontally. So we have a top and a bottom now. So we have 2 bisecting lines, one from top to bottom and one from left to right. And there's our 90-degree angle. And what we find with that is we have 4 equal parts. 1, 2, 3, and 4. So we actually have 4 equal parts to our circle. So we can see now that our missing slice is one of those pieces, one of the 4 pieces. So it's 1/4. Our missing slice is 1/4 of our circle. So we know from that that the missing slice is 1/4 of the total area. And we know that our total area is 28.26. So there is our missing slice, one of 4 pieces. And so that's 1/4. And we know that 1/4, the numerical value of 1/4 is 0.25. So let's plug in our formula again. The missing slice is 1/4 times the total area. And we know our total area, so it's 1/4 or 0.25 times the total area, 28.26, which gives us our solution. The area of the missing slice is 7.065. So we found the area of our missing slice, and we know that it is 7.065. That concludes our lesson for today. We'll see you on the next one.